Okay, now, next thing we did was we did make the table for y equals 2 to the x. Now, it took us way too long to do that. We wasted a lot of class time in doing this and in waiting for people to construct graphs, and that's another reason you have to be able to do these quickly. Most important reason, because you need to access this knowledge when you need it and not have to work it out painfully and slowly, but the end of which you've forgotten while you were doing it. Got to get it instantly. And the other reason is so, of course, and it's also very important, so we don't waste a lot of class time. Or so we don't leave you behind when we do this in class. That's extremely important. But that's up to you. You got to practice these. Okay, so you got the y equals 2 to the x function, and people didn't know what values to use. Well, if you're practicing these and following the instructions you had in the first day, you would. So make sure you do. The numbers would be -2, -1, 0, 1, and 2. Those are the numbers we use for y equals 2 to the x. There's a reason for that. Okay, we always go from -2 to 2 when we're doing the basic points of the basic graphs. Now, sometimes you want to go beyond that for various reasons, but that's what we do. Okay, those are the basic points. And they usually include -1/2 and 1/2, but they don't for 2 to the x for a very good reason. And that's because we only use x values for which we can get an exact value for y. That's the rule. Or an undefined value, because undefined values are important to note. Okay, so if x is -2, well, 2 to the x is 2 to the -2, and I'm not going to explain why 2 to the -2 is 1/4. That was done very early. And -1 gives you 1/2. -1/2 would give you what? 2 to the -1/2 is 1 over 2 to the 1/2, which would be 1 over the square root of 2, and you can't express the square root of 2 exactly. As I said in class, it's about 1.4 because 1.4 squared is 1.96. It's about 1.41, which is even closer. That's about 1.414, which is even closer, but there's no end to it. The numbers that you get, the digits that you get as you go to more and more decimal places, never repeat, and they never terminate. So you can't write down this number in decimal form so that you can plot it with complete accuracy. And we don't, right now, want to be dealing with the degree of approximation that you need to get a good result. We really don't need the coordinates of this point or this point to draw a good graph, which looks like this, and which you should be very familiar with. Okay, if you just have these 5 points, that's enough. Okay, so we omit this and we omit the 1/2, and then the 0, 1, and 2 give us these values. Again, that's very easy. The negative exponents, well, we talked about that early, and you need to have dealt with that. And if you didn't deal with it, make sure you do. Okay? So, here's our table. Well, here's our graph. You can ignore this for a moment, but right here is the graph, so maybe I'll shade that in a different color. And here are our points from the table. Here's a smooth curve. And there's no subtlety to this curve. It's very clear how to draw it. Okay. Now we did more than that. So we went, one reason we did this is so we can talk about inverse functions. Because this is coming up probably next week in class. So we want to anticipate it. Okay, so we have inverse function. The inverse function to this function is you can obtain a partial table of the inverse function just by flipping the columns, so that this becomes your x column and this becomes your y equals g of x column. Like the instructions said, let's call this y equals g of x just so we have something to call it. And when you do that, you get something that has a graph that looks like this. And some people got that graph very quickly, and everybody was on track to get it, and we did. Some people should have been a little quicker about it, and will be with practice, okay? So if you haven't practiced enough to get this in just a couple of minutes, you need to practice more. Okay, that's all it takes, okay? That and knowing the rules for negative exponents and dividing by zero and stuff. Okay, well, anyhow, there's our g of x function. Now, I'll observe that our g of x function, I just sketched it here and I didn't bother plotting the points. That didn't come out completely accurately, but the thing I've indicated here is that every point on this graph, if we reflect it across this line at 45 degrees, then that means we go across at a right angle to an equal distance on the other side, and those distances don't look that equal. They should have been. Remember, rough sketch. Didn't want to take time to construct it. We'll do that later when we really get further into inverse functions. Anyhow, the inverse function looks like this, okay? Now, if you take this purple graph, flip your paper this way, and then, well, let's say, take the purple graph, rotate it 90 degrees, then flip it this way, you're going to get this graph. I think I did that right. Rotate it 90 degrees, yeah, that's going to be down there. Yeah, I think I'm right. Okay, so it's a very simple idea. An inverse function is a very simple idea. Now there's algebra that has to be done with inverse functions, and that's less simple. And the whole algebraic relationship among functions is a little less simple. But we start with this idea of just reversing the x and y values and seeing how these graphs relate, and we have a very good start on inverse functions.